you see the essential parts of any C program. In this video, we will learn how to sort the elements of an array. Sorting means, suppose an array contains 4 elements 5, 3, 1, 2. So the sorting means that you have to make it either in ascending order or in descending order. So this array containing 5, 3, 1, 2 in sorted form will be 1, 2, 3, 5 or 5, 3, 2, 1. In this video, we will sort the array elements in ascending order and using two concepts. First one is the bubble sort and the second one is the recursion. You know, recursion, in recursion, a function calls itself. Now, to understand the mechanism of the bubble sort, first see this thing. Here you see, suppose an array contains 4 elements. 4 elements, suppose it is 7, 1, 3, 2. And I have to sort it using the bubble sort. And you must know that in bubble sort we swap adjacent elements of the array. I show you this mechanism here. I say the adjacent elements. This means that at a time we take a pair. So in this array you see there are 4 elements 7, 1, 3, 2. So the first pair will be 1, 7, 7, 1 and the second pair will be 1, 3 and the last pair is 3, 2. So there are 3 pairs. Numbers are 4, data are 4, the pairs are 3. So pair is always less than the size. Suppose you take an array of size 5, then the pairs will be 4. So I here start to swap taking pair. First pair is 7, 1. So swapping means at the place of 1, at the place of 7 it will be 1 and at the place of 1 it will be 7. Okay, I have done the work for the first pair. Now we do the same for the second pair, that is 7, 3. So we swap these two and one more thing you must keep your mind in your mind is that you have to swap only when the first element is greater than the second. Here you see 7 is greater than 3, so we should swap. If it is not the case, then there is no need to swap. So 7 is here, the first element 7. In this pair 7, the first element is greater than the second, so we need to swap these two elements. So here will be 3 and here will be 7. Okay, now the last pair is 7, 2. Still in this pair the first element is greater than the second, that is 7 is greater than 2. So again we swap these two. So here it will be 2 and here it will be 7. Now by doing for this last pair, we have done the swapping. We have completed for the all pairs, for the all three pairs. Still you see that our numbers are not in ascending order. Then you will think that what is the benefit of bubble sort? You know, obviously, truly in bubble sort we swap adjacent elements. We did the same but not got the array in sorted form. Okay, it is true. If you take pairs and swap, you are not getting the elements in ascending order. But one thing is there, and that thing is you must notice, you must observe in this that the largest element, that is 7, is at its right place. 7 is the largest element, and you know, if you go to arrange the elements in ascending order, then the largest element should be at the end, and obviously that is here. Obviously we see the same, the largest element, that is 7, is at the end. So we can say that at least the largest element is at its right place. So we do the same thing, that is we have to take the pairs from the beginning and have to swap. But for the next time there is no need to involve the largest element because it is already at its right position. So for the next time we take only these three elements. That is, for the next time you have two pairs, 1 3 and 3 2, and after that the array size becomes one less after each complete swap from the last to the end. The array size becomes one less than the earlier. This is the mechanism of the bubble sort. So in this way I show you. For the next time you see we have three elements, 1 3 and 3 2. Okay, so the first pair is, we have, as I said earlier, that we do not need to do anything with 7 because 7 is at its right place. So I am marking it with red. This means that this 7 is okay. Now it remains three elements, 1 3 3 2. Okay, so the first pair is 1 3, and as I said, you have to swap only when the first element is greater than the second. Here 1 is less than 3, so there is no need to swap 1 and 3. Now we go for the next pair. Next pair is 3 2. So here you notice 3 is greater than 2, so it is needed to swap. So here will be 2 and here will be 3. Okay, now we reached at the end, and you see the second largest element this time is at right place. So I am marking it with green because it is at right place. Now it remains only two elements. So for the next time we consider the array containing only two elements, these two elements. So with these two elements you can make only one pair, and in this pair the first element is not greater than the second, so there is no need to swap. Our work is okay. This means that this 2 is at its right place. So I am going to make it green. Now it remains 1, that is the array with one element, and you know any array with single element is already sorted. There is no need to sort it. So and okay, and obviously you see, you with one you cannot make a pair. This is already sorted, so I am going to make it green again. And now our process, the entire process of bubble sort is complete, and you see now there is an array, a sorted array in front of you. 1 2 3 7. This is in ascending order, and we have to do the same thing with a C program. So let us see the C program. You see, this is the essential part of any C program. I am going to paste certain part of this program. I have pasted from this to this. These parts, this part enables a user to get the size and to get the data for the array. Now I have made you understand the mechanism of a bubble sort. Now in this video we will do the bubble sort, but we will use the recursion. Recursion means when a function calls itself, it is called recursion. So it is a function call, so obviously I have to declare a function. Void type function means it is not going to return anything, and here the function name is fun, and in this we take 3 arguments. Int star, you know, int star is for the address, int is for the integer, and also a third argument of the same type, that is int. Now we make a function call. You know, function starts to work when it is called, and you must also know that any function is called inside the main function. You see here it is the main function, because any program, any part of the code, any program runs starts from the main function. This is the body of main function. This whole thing is the body of the main function. So to call a function, we calling for the first time is done inside the main function. So here our function is fun, so I am going to call it. So here you see there are 3 arguments. You see, first one is an address with int star, and the last 2 are the integers. So here I pass a, you know, a is the array name, and you must know that array name is the address of its first element, and here I pass 2 integers n and n, the array size. Okay, now the time comes for array definition. How the function should work is written inside function definition. So here I type int star, int star a. You can take some other letter as well, that will also work, that will also give you the same result. I take the same star a. Here int m and here int n. This m, as I have shown you in the beginning, that for the next run the array size gets reduced. First it was of size 4, thereafter it becomes of size 3, thereafter 2. So that for that size I have taken here m, and this n stands for that size that was at the beginning, that is initial array size, and in our example this was 4, a constant. Throughout the program it will remain constant, but the second argument, the second integer m, will change after each complete run. You see, first it was 4, thereafter it becomes 3, and at the end it becomes 2. Okay, now here I type inside the body of this function, I take an integer temp because I have to swap. Obviously the bubble sort is based on swapping, so for that I take a variable temp and I for the index number, and here I use the for loop, and the index starts from 0, and this must be less than m minus 1, because I have shown in the beginning that if array size is 4, then the pairs will be 3, one less than the size. If you take 5, then the pairs will be 4. So I have accordingly here typed I less than m minus 1, and thereafter I plus plus. Indices are at a distance 1, so I plus plus, and here thereafter I have to swap, but I have already said in the beginning that no need to swap every time. Swap only when the first element is greater than the second. So here will be a condition if, and the first element, suppose it is I, so it should be greater than the second element, that is I plus 1. If this is the condition, only then we have to swap. So if it is true, then it will go inside the body of if keyword, and here the cursor blinks inside the body of if keyword. So here I use the swapping if condition is true. So here will be a I, the first element will be stored in the temp variable, and this first element will take the data residing under the second element. So here will be I plus 1, and at the end this ai plus 1 will store the data in the temp, that is the first data. Temp is storing the first data. Okay, this swapping part is okay. Now I have shown in the beginning that if you have gone from the first pair to the last pair, thereafter you have to take an array of size n minus 1. You have to keep the last element undisturbed. So for the next time the array size will be 1 less than the previous one. So in this way array size will reduce again and again, and there will be a time when the array size will be 2, the last time, because with 2 we can make a pair, and this pair, if the first element is greater, then we can swap, and thereafter there is no need to swap, because after that the array size will be 1, and you know any array with size 1 is always sorted. So when its size becomes 1, that is the time to print our result, and that result will show you the sorted array. So here will be the condition. When you swapped all the pairs for the first time, then the array size will get reduced by 1. So obviously there will be condition, and the condition is f. You know, array size is being reduced by 1. So in this part, in this function called array size is this m. So now it becomes m minus 1, 1 less. And you know, for swapping the array size must be at least 2, because with 2 elements you can make a pair. You cannot make a pair with one data. So this must be greater than 1. If it is 2, this means that for the next time means the array size is 1 less, so m minus 1, and that should be greater than 1. So we again call the function name is fun, and this is the reason it is called recursion, because function is calling itself. You know, this whole thing is the body of this function fun, and inside that body you see the same fun. This is the reason why it is called recursion, because fun is inside its body. It means that the function fun is calling itself, so it is called recursion. So we will call it again if the array size is at least 2 or more than 2. So here will be a comma, this time m minus 1, because the array size gets reduced by 1 after each complete swapping. And here will be the third argument n, that is constant. This n belongs to initial size of the array. Now this will again do the same swapping, because we are calling the same function, and it may be the case that at the end the array size becomes 1. So there is no, as I said earlier, there is no need to swap the elements now. When it becomes 1, that is the time to print the elements. So I use here the printf function to print the array elements, and you know array elements are with index numbers. So for that we use the for loop, and here again I equals to 0, I is less than n, and I plus plus to increase the size after each run by 1. And here we use the printf function. Before that we can write a printf function to create a new line. By creating a new line, we see the output in a attractive way, in a good looking way. So I have written here printf function to create a new line, and now we use the printf function inside the else keyword, to see the result. Here will be %d because array elements are integers, and here I add \t to see the elements of the array at a tab distance, and here ai because array name is a and I is the index number. As the index number goes from 0 1 from 0 to 1 to 2 to 3, so you will see the array elements, the sorted array elements in a continuous manner. So here I think our program is ready. I show you the entire program. This is the upper half of this program, and this is the lower half of this program. Okay, I show you again. This is, I think, a medium sized program. Here is the upper half, here is the lower half. Okay, now let us run this program. Let us see it is true or not, it is correct or not. It says enter the array size, so I place 4. Since I have placed 4, so I have to enter 4 integers. I take randomly 4 integers: 78, 90, 45, 23. Okay, I have entered 4 numbers. Now I am going to press the key enter. You see the result. Here is the result, and you see these numbers are obviously in ascending order. So our program is correct. In this program I am going to repeat again. In this program I have used two things: bubble sort, that is swapping of adjacent elements, and the second concept is recursion. Recursion means calling of a function. When a function calls itself, it is called recursion. So with this I have uploaded 2 programs on bubble sort. The first program, the previous video, in the previous video you will see a program on bubble sort, but in that I had used nested for loops to sort the array elements, but in this program I have used recursion to sort the array elements. You should notice the differences between the two. Both are important. Okay.